Hi guys, it's me, Sarah, Director of Awesome here at the IMAG, and for today's STEM at Home demos, we're going to be working with vegetable oil and water because that's something I'm hoping you have at home so you'll be able to do some of these experiments on your own. And so we're going to take a look at these and do a couple different things with them. So first up, what I'm going to do is bring over here, I've got vegetable oil, I've got water, and if you've ever heard the expression oil and water don't mix, I'm going to explain why. So there's two really big reasons why. The first one is they have different densities. Density is how much matter is packed into a space, and vegetable oil has less matter packed into its space than water does. So what that means is one is going to sink and one is going to float all the time. The other reason that they don't actually mix is because the vegetable oil is what we call hydrophobic. What that means is the molecules inside vegetable oil are literally afraid of the molecules inside water, and so they won't actually mix. It won't matter which way you pour them. If you shake them up, they'll still separate out. So I'm going to go ahead and show you that. So what I'm going to do right now is I'm going to go ahead and I'm going to pour some vegetable oil into a plastic cup. And again, this is just to show you can do this at home. And then I'm going to come over here and I've got some water. I'm going to pour some water in here. So I poured the vegetable oil first, water last, and what I want you to see is the vegetable oil still ended up on top. Now I'm going to do this again, but this time I'm going to pour my water first, and then I'm going to pour my vegetable oil, and I want you to see the same thing happened. It still settled out with the vegetable oil on top, the water on the bottom. Again, that's because they have different densities. So what I'm going to show you next is something that you can make at home. And so this is called a lava lamp. And so this one you're going to need an empty bottle. It can be a water bottle, soda bottle. And then what you're going to want to do is I'm actually going to use a funnel for this just to keep it from being too messy. I'm going to go ahead and pour some vegetable oil in here. Alright, so we're going to pour our vegetable oil in. I'm going to add some more. And with this, you want to make sure that you're filling your bottle about 2/3 of the way full of vegetable oil. And then you're going to come over, and what I'm going to do, just because I want it to be a little bit more fun, is before I add my water, I'm going to put a little bit of food coloring. So at this point, I can also start talking again about chemistry and the difference between a physical change and a chemical change. So a physical change means I change the way something looks, but I've got the same thing. Chemical change means I make something new. So in this case, I'm dyeing my water green. So it's still water, I just dyed it green, so that's actually going to be considered a physical change. So we're going to go ahead and pour this in. So I'm going to pour my, my green water in here. And what you're going to start to see is, just like I said, it's going to start to settle out. And so our water is going to go down to the bottom, vegetable oil is going to stay on top. Now, in order to make this a bubbling lava lamp, if you have at home, what you're going to want is to have Alka-Seltzer, and so I have a big box of it here, so antacid. You want to be careful if you're working with kids with this. This is considered medicine, so adults, make sure you have some supervision. So you want to take this, and you take this tablet, and you're going to break it up into pieces. And what happens is when you mix Alka-Seltzer with water, it makes carbon dioxide gas. So that's actually a chemical reaction that's going to happen. It's going to release carbon dioxide gas. Again, this experiment, really cool. It also works with solids, liquids, and gases. So we have our liquids in here. We have our vegetable oil, we have our water. Now we're going to add a solid. This is going to be our Alka-Seltzer. When I put this in, it's going to make carbon dioxide gas. It's going to sink to the water, make that gas. The bubbles are going to try and escape, and it's going to make that really cool bubbling lava lamp effect. You don't want to put a cap on this because you are making carbon dioxide gas, and you don't want to pressurize your bottle. That could be dangerous. You want to leave the cap off, but we're going to go ahead and drop our pieces. It works better actually if you break it up into small pieces because it actually will dissolve faster and make that carbon dioxide gas. And so we're going to go ahead and put that in. And the cool thing is each packet comes with 2 tablets, so I can even add some more. And the neat thing is when this reaction stops, you can do it again. So you can actually just add more of the Alka-Seltzer and it'll still do the same reaction. And so we've got that really cool bubbling effect here. If you really want to make this look like a lava lamp, you can actually dim the lights, put a flashlight through it, get that really cool shimmering effect there. But so that's what you're seeing right now is all those gases are trying to escape. They're making that really cool bubbling effect in your lava lamp. So I'm going to move this one to this side. Now, I'm going to show you something else. So you may be wondering, there's a big aquarium up here. The next thing we're going to look at is another property that happens with vegetable oil and water. And actually I'm going to switch these and do this one first. So this is a really easy one that you can do at home. If you just take an empty 2-liter, fill it up with water. You can even just do this in a glass as long as you have a really big glass of water. We're going to talk a little bit about light and refraction. So light can reflect and it can refract. when something reflects, it bounces off the surface and comes back to you. When it refracts, it actually bends the light. And so what we're going to do right now is I'm going to show you that when light moves through water, it refracts and it bends. And so you can do a really cool demo with that. All you need is a piece of paper, some markers, and you can draw pictures on it. You want to draw pictures that have a direction. Like I'm doing an arrow on this one, and I'm going to do eyes that are kind of looking to my right, your left on here. And what you want to do is if you hold it up behind your water, so I'm hoping the camera zoomed in on this. So if you're looking through here, what you should see is this arrow is pointing this way, but if you look through the water, it's going to turn and point the other direction. So really simple little trick that you can do to show that light is actually bending as it goes through the water. So that's that, and I can switch over. I've got my eyes, so if I put it behind, it should make the eyes look like they're looking the other direction. So this is a really simple activity you can do at home that has to do with refraction. And so we're going to come over here now, and I'm going to show you again how light can be affected by different mediums. So again, we've got our water, we've got our vegetable oil. So full glass of water, this one has a half glass of water, half glass of vegetable oil. So what I want to show you is that light moves through different mediums at different speeds. So I've got a test tube here. The reason we can see the test tube is the light moves through the air, the air inside, the glass, out the other side into the air, and it changes speeds, and we're able to actually see the test tube. If I put it in water, which I'm doing over here, you can still see the test tube. It gets a little bit harder. So what I'm going to do next is I'm going to take a little bit of this water, make a little bit of a mess too, that's okay, and we're going to go ahead and we are going to technical difficulties, it's okay. I'm going to put it back in here. It's a little bit harder to see. So if I do a comparison, so if you look at the two test tubes that I have inside of here, I want you to notice it's a lot easier to see the one that's filled with air versus the one that's filled with water because we've changed the medium that the light is traveling through. So here's what I'm going to do now. We're going to switch it over. I've got a glass over here that has half water, half vegetable oil, and I'm going to do this one first over here. I've got the aquarium over here that is filled with vegetable oil. So what I'm going to do is I'm going to go ahead and dunk this in here, and what I want you to notice is right now you can still see it. That's because the light is passing through the aquarium, the vegetable oil, the test tube, the air inside the test tube, the vegetable oil, back through the aquarium, out into the air. So what I'm going to do now is I'm going to let it fill up with vegetable oil. And what you should see is it looks like it disappears. And that's because, oddly enough, light travels through Pyrex glass, which is what this test tube is made of, and vegetable oil at almost the same speed. So it kind of makes it look like it's invisible. So I'm going to take this out. We have this test tube. It's now filled with vegetable oil. So what I'm going to do is I'm going to put it in this glass that has water and vegetable oil, and I want you to see what happens. So what you're going to notice is, if you look at this glass, you can see it down in the water, but it looks like it becomes invisible in the vegetable oil, and then you can definitely see it out here in the air. So again, it has to do with the speed of light and how it's traveling through those different mediums. If I take this one that's filled with water, you can see it in all the substances, but again, look at the difference between the two versus the vegetable oil and then also with that water. Now, for you at home, what you want to do is look around in your kitchen and see if you have any kind of baking dishes or items like that that are made of Pyrex glass. And so that's the type of glass that this works the best with. But you can test this out with things like straws, small cups and glasses, and things like that, just to see what happens when you put it in these different substances and see what happens to the speed of light. What I'm going to do right now, though, is I'm going to come back over here. So I'm going to grab another test tube, and I'm going to come over here. You're probably wondering, I've got this big aquarium over here. I'm not sure you're going to have an aquarium that you can fill with vegetable oil. By the way, if you are a kid watching this video, please make sure you get your parents' permission before you start pouring out all their vegetable oil. You can't do this experiment and then try to blame me. You will actually get in trouble. So make sure you've got permission. Maybe do it on a smaller scale in one of these cups like this. But for me, I've got my aquarium, I've got my vegetable oil. So we're going to take that test tube, and I want you to watch. You guys can see it? And now it's gone. So my test tube has now disappeared in here. And if you were wondering why I have this big glove on, here's why. Before I did this segment, I hid some really big objects in here. So I'm going to go ahead and pull this out, and I'm going to show you all of these items were actually hiding in the aquarium. Ooh, that one's really stuck to the bottom. Ah! So I hid all of these items in here. And again, because of the way the light travels through the vegetable oil and the Pyrex, it makes them almost invisible, and it looked like we had an empty tank, when in reality, we had a tank that was filled with different items. So again, this is just an example of some things you can do at home. Vegetable oil and water. You can come over here and test density by layering them. You can actually make a lava lamp and make it bubble and get more into the chemistry side. You can also test out different items and see like how the light travels through those different mediums. But there's different ways that you can do this. The cool thing is you can reuse these ingredients for this experiment and keep doing this over and over again and kind of change what you're doing each time. So thank you guys for watching. I would absolutely love to see the experiments you guys do at home with vegetable oil and water. Definitely post them on social media and you can tag us. I'd love to see what you guys are doing. Make sure you tune into our next video. Thanks. Alright, hi guys, I wanted to give you another extension that you can do with the vegetable oil and water experiments as related to density. So remember I said water and oil have a different density, so they actually stack on top of each other. Here's the cool thing. There are other liquids that you can do this with. So this is going to be something, again, make sure you're getting permission. Don't just start raiding the cabinets. But if you want to get some different liquids and test them out to see if they mix or if they separate based on their densities, you can do that. I'm going to give you some hints and examples on things you can use, and then we're going to do one really quick. So stuff that I have pulled out is I have corn syrup. I dyed it red. I have honey. I have dish soap. The blue one right here is actually water. This one is vegetable oil. This is lamp oil. You can also use rubbing alcohol as well. It's going to be up to you. You can use other things. Milk is a good one. Maple syrup can be used as well. So there's different things you can test out, but we're going to go ahead and try and stack some of these liquids. So I'm going to go ahead and pour my corn syrup. You want to try and pour down the middle of the cup so it doesn't have drips down your cup. Again, because these liquids have different densities, you don't actually have to pour them in order. They may mix a little bit as you first do this, but eventually they will actually settle out and you'll get those really cool layers happening. So we're going to pour this one, and actually this is our first test on if I pour them out of order, will it work? Because honey is actually more dense than corn syrup. So this is actually going to end up sinking to the bottom and going underneath our corn syrup. So again, it might not happen at first, but if you leave your cup sitting out on the counter, even if they mix when you first do it, they will eventually settle out and you will get those really cool layers. Again, the thicker liquids are going to obviously take longer to pour. So we're going to wait for that one to start settling out. We're going to keep going. We've got our dish soap here. Pour it on top, and then we're going to come over here. I'm going to skip the water for now just because I'm trying to get you some fast layers going on, and I'm going to pour my vegetable oil on top, and then I'm going to come on top with our lamp oil. So like I said, right now you're going to see that things are trying to mix up a little bit, but what you want to do is leave this sitting out on the counter, and what's going to happen is over time you're going to get those really clear layers happening because they all have different densities. They're all going to settle out and make those really cool layers happen. Now you can take this a step further. If you want to take some items from around the house that also have different densities, you can go ahead and drop them in and make this into a sink and float experiment. So what I have in this little cup is I have a marble, I have a ping pong ball, I have a soda cap, and I have a cork. And what I can actually do is if I drop these in, if you look here, the marble has sank all the way to the bottom. If I take the cork's going to float on top. If I drop my bottle cap in, it's also going to float. So what you want to do is you want to drop different items in, and you'll actually get items that will sink at different levels. A dice from a game is also a really good one you can use, and that one should actually sink about halfway down. So again, this is going to be a density experiment. You're going to get really cool layers happening. So test this out. Try some different things. Again, I'd love to see your experiments and see what you guys are coming up with. Make sure you tag us if you share them on social media. So this was our 11 a.m. STEM at Home experiment. And so if you tune in at noon, we're going to be doing our Meet the Keeper. So make sure you guys check that out. Have fun at home. Thanks for watching.